Both in Uniswap V2 and in Uniswap V3, during the swap, you can actually receive a token before you put the token in. We'll use this mechanism to build a smart contract that will do an arbitrage between two Uniswap V3 pools. For example, let's say that we have two Uniswap V3 pools, DAI WEF with 0.3% swap fee and another pool DAI WEF with 0.05% swap fee. And let's also say that in the first pool, DAI WEF with 0.3% swap fee, WEF is selling for 2,000 DAI. And in the second pool with 0.05% swap fee, let's say that WEF is selling for 2,100 DAI. Here we can execute an arbitrage to make some profit. To initiate an arbitrage to buy the WEF from the first pool, we won't need to deposit any DAI. This is because we're going to do a flash swap on pool 0. Here we'll say that the first pool is pool 0 and the second pool is pool 1. So we do a flash swap on pool 0. Without putting any DAI in, we'll be able to request for WEF. On the second step, we'll swap this WEF that we got for DAI. This is executing a regular swap on pool 1. And once we have DAI, on the last step, we'll repay pool 0 with the DAI. The profit from this arbitrage will be the DAI that we receive from pool 1. This is from swapping from step 2. And then the DAI that we repaid in step 3. The difference will be the profit in DAI. Okay, let's write some code. To begin with, I'll first declare some interfaces that we're going to need for this contract. We'll need the interface iSwapRouter02 to execute a regular swap with pool 1. To initiate a flash swap, we'll directly call the pool, so we're also going to need the interface for a Uniswap V3 pool. And I'll also declare two interfaces, IERC20 and IWEF. Okay, next I'm going to declare some constants. First, I'll declare the contract address of SwapRouter02. And then inside our contract, we'll initiate the iSwapRouter02 interface, passing in the address of the SwapRouter02. I'll also declare some constants, min square root ratio and max square root ratio. These constants will be handy when we directly call Uniswap V3 pool and then call the function swap. Okay, next I'll declare three functions. Function, flashSwap. This will be our entry point. This will be the function that we'll call to initiate the arbitrage. Next, I'll also create an internal function, and this will be a simple wrapper on calling the function exactInputSingle on SwapRouter02. Now, when we initiate the flash swap, we will directly call the Uniswap V3 pool contract and then call the function swap. Then we'll ask this pool contract to send us some tokens. When we do this, the pool contract will call back into our function. The specific function that we'll need to implement is called function Uniswap V3 swap callback. This is the function that Uniswap V3 pool will call back into, and then inside here we'll execute our arbitrage and then send the amount of DAI was requested back over to the pool contract. Okay, so let's begin by writing the function flashSwap. This is the function that will initiate the arbitrage. For the input, I'll pass in the address of the first pool, pool 0, and to identify the second pool, I'll pass in three parameters, uint24, fee 1, and address token in, and address token out. With these three parameters, we can identify a pool in Uniswap V3. Okay, and the last parameter that we'll pass into this function is uint256 amount in. This will be the amount that we'll have to pay to pool 0. Okay, next we'll directly call the function swap on the pool contract. So to do this, I'll first use the interface Uniswap V3 pool 0, and then we'll call the function swap. To call the function swap, let's look at the parameters that we'll need to pass. So these are the parameters that we'll need to pass. For the recipient, this will be the receiver of the token. Let's set this to address this. 041. Is this trade going to be 041? If it is true, it means we're sending token 0 and then receiving token 1. Now, how can we figure out whether this trade will be a 041 or a 140? So say boolean 041 is equal to, well, way that the tokens are identified as token 0 and token 1 is by ordering the tokens by the address. So for example, when we compare token in and token out, if token in is less than token out, then we know that token in is token 0 and token out is token 1. This will be a trade for 041 if token in is less than token out. Otherwise, token in will be an address that has a greater value than token out. So we know that token in will be token 1 and token out will be token 0. Okay, so that's 041, 041. The next input, amount specified. And notice that this was an int 256. We're going to put token in, so this will be int 256 amount in. Okay, next, uint 160 square root price limit x96. This will be the limit on the price that we're willing to accept. For this example, we'll keep it simple and then either set it to max or min depending on the direction of the trade. So this is where the constant that we declared over here becomes useful. Here we have min square root ratio and max square root ratio. When we execute the function swap and then pass in the square root price limit over here, the value that we pass over here must be greater than this number and less than this number. So let's say over here, uint 160 square root price limit x96 is equal to, if this swap is a 041, then the square root price will decrease. Otherwise, if the trade is a 140, then the square root price will increase. So using this fact, we can figure out what we should put for square root price limit x96. So say 041. If it is a 041, then the price will decrease. And the minimum that it can decrease to will be min square root ratio plus 1. Otherwise, square root price will increase. And the maximum it can reach to will be max square root ratio minus 1. Okay, so now we figured out square root price limit x96. Square root price limit x96. The last parameter that we'll prepare is data. This will be the data that will be sent over to Uniswap V3 pool contract, and then this data will be forwarded to the callback, Uniswap V3 swap callback. We'll encode the data that we're going to need inside the callback here. So say bytes memory data is equal to abi.encode. We'll encode message sender, the message sender of to the function flashSwap. And this is because when this function is called, it's going to be called by the pool contract. So message sender will be the pool contract. And we want to know who the message sender is when this function flashSwap is called. So we'll encode message sender, message.sender. Next, we'll encode all of these data. So this will be pool 0, fee 1, token in, token out, amount in, and we'll also encode this 041. 041. And then over here, I'll put data. Okay, so that completes the function flashSwap. Again, this function is going to initiate a flashSwap to kickstart the arbitrage. When we call this function, it's going to call swap on pool contract, and the pool contract is going to call back into the function Uniswap V3 swap callback. For the inputs, we'll receive 3 inputs: amount 0, amount 1, and data. Notice here that amount 0 and amount 1 are int 256 and int 256. When these numbers are negative, it means that the tokens came out from the pool. For example, if amount 0 is negative, then this means that amount 0 of token 0 came out of the pool. And if amount 1 is negative, this means that amount 1 of token 1 came out of the pool. Here are the steps that we'll implement inside this function. Let's first start by decoding this data. So what I'm going to do is I'm going to copy this and then paste it here so that we know what we encoded. Okay, and then say the first data that is encoded will be address, message sender, so I'll call this caller. The second one is the pool, so say address, pool 0. Next one is fee 1. Okay, I'm going to scroll back up. Fee 1 is encoded as uint24. So going back down, we'll decode this as uint24, fee 1. Next is token in and token out. Address, token in, address, token out. Okay, next is amount in, uint256, amount in. And that's the 041. This was a Boolean variable, 041. And we'll decode this by using the function abi.decode, decode the data, and the types to decode it as are, I'll copy this, paste it here, and then remove the names. We're just keeping the types here. Okay, once we decode this data, next we'll call the internal function swap to do a swap on pool 1. We have not implemented this internal function called swap. What do we need to pass in for the inputs here? Well, if I scroll down, to call the function exact input single on swap router 02, these are the inputs that we'll need to prepare. So here, say token in, I'll leave it as a question mark for now, token out. We also need to pass in the fee. These three parameters will identify the pool to swap on. For the recipient that you see over here, we'll set it to this contract. So we won't need to pass this as an input to our internal function swap. Okay? Amount in, and amount out minimum. We'll call this amount out min. And for the square root price limit x96, we'll set it as 0. By setting this as 0, the swap router will automatically set the square root price limit x96 when it calls the pool contract to these values that you see over here. So we'll call this internal function swap, and we'll ask this function to return the final amount of token that came out. So uint to 56, I'll call this buy back amount is equal to. And then to calculate the profit, what we'll do is say uint to 56, profit will be equal to the amount that came out from swapping on pool 1, buyback amount, minus the amount that we'll have to pay back to pool 0. This is encoded inside amount in. Say amount in. So this is how you will calculate the profit. Next, let's go back to this swap function and figure out what parameters that we'll need to pass into this function. So to begin with, on pool 0, what we did was we first requested token out, and we promised pool 0 to pay back with token in. So when this callback is called, the token that we have is token out. And on pool 1, what we want to do is swap this token out that we have so far, token out, with token in. So over here, token in will be token out from pool 0, and token out will be token in from pool 0. Fee is easy. This is the fee that is decoded over here. So this will be fee 1. Amount in. How much amount do we need to pass in here? Well, when this callback is called, we got back out token out. And what is amount out over here? To figure this out, we'll need to look at these two parameters. So remember I said that if these numbers are negative, then this means that this much amount came out from the pool. So to figure out what amount out is, we can look at this 041. And since the amount that came out will be negative, we'll need to turn it into a positive number. So I'll declare a variable uint amount out is equal to, this is the amount out that came from pool 0. So is this trade a 041? 041 on pool 0. Is this a swap for 041? If it is, then we know that the amount out is inside amount 1 that we get from the input over here. And this will be a negative number, and we want to turn this into a positive number, so we'll put a minus, and it is int 256, so we'll cast it into uint 256. Otherwise, if the trade was not a 041, then it would be a 140, which means that the token out was token 0. So again, you'll say uint 256 minus amount 0. Okay, so we now figured out what amount out is. Let's put this back over here. When we do a swap with pool 1, we'll take this amount out that we figured out over here and then use it as amount in. Amount in for swapping with pool 1. Amount out. Okay, how about amount out minimum? What is the minimum amount that we want to receive from pool 1? Well, when we do a swap on pool 1, we're going to put in token out relative to pool 0 and then get back token in. The minimum amount of token in that we'll need to repay pool 0 is this amount in. So when we're swapping with pool 1, the amount out minimum should be amount in. Otherwise, there's no arbitrage profit. Okay, next, let's complete the internal function swap, and then we'll come back to this function, Uniswap V3 swap callback, to finish repaying pool 0 and then paying the profit over to caller. Okay, so first I'm gonna copy this, and then I'll paste it here. For the input to this internal function swap, you'll need to pass in token in, address, token in, address, token out. Fee will be uint24, uint256 amount in, and uint26 amount out min. And when we call this function, we want to return the amount that came out from the swap. Returns uint256 amount out. Inside here, the first thing that we'll do is approve the router to spend. So say IERC20 token in dot approve the address of the router for the amount in. Next, we'll call the router and call this function. So I'll copy this struct and the function and then paste it here. Let's start by preparing the parameter. So the parameter is iSwapRouter02 dot exact input single params memory, I'll call it params, is equal to, I'll copy this again, then paste it here, and this is the parameter that we'll need to prepare. Token in will come from the input, token in, token out will also come from the input, token out, fee will also come from the input, fee, recipient, we want to send the token out to this contract, so this will be address, this, amount in will also come from the input, amount in, amount out minimum, this will also come from the input, amount out min, and square root price limit x96. We'll set it to 0. Okay, once we have the parameters prepared, next we'll call this function exact input single on the router contract. Router.exactInputSingle, pass in the parameters, and then it's going to return a single input called amount out. We declare this amount out as an output, so we'll just assign it. Okay, so that completes the internal function swap. Let's go back to finish off Uniswap V3 swap callback. So we're not going to need this. And then the last part is to repay pool 0 and pay the profit to caller. So here I'll say IERC20 token in dot transfer to pool 0 for the amount in. This is the amount that we need to repay pool 0. And the profit will be IERC20 token in dot transfer to caller. This will be the caller to the function flashSwap. To the caller, pay profit. And lastly, there's a chance that profit is 0, so we can require that this profit is greater than 0. Profit equals 0. Okay, that completes our arbitrage contract. So again, what this contract is going to do is it's going to initiate an arbitrage by first requesting for token out from pool 0. Pool 0 will call back into this function, Uniswap V3 swap callback. Inside here, we'll execute a trade with pool 1, get the token out, and then from the token that came out, we repay pool 0, and then whatever that is left over, we send to the caller. This will be the profit. So I wrote a test, and before we execute it, I want to quickly show you what's going on. Inside the test, we'll simulate an arbitrage between DAI-WEF pool with 0.3% swap fee and DAI-WEF pool with 0.05% swap fee. The profit that we can make is really small, so the amount of DAI that we'll send will be 10 DAI. And before we execute the arbitrage, inside the setup, I'll first create an arbitrage opportunity. What it's going to do here is first, it's going to make WEF cheaper on pool 0. And this is done by selling 500 WEF on pool 0. Once WEF is cheaper on pool 0, we execute our arbitrage and print out how much profit we made by sending 10 DAI. Inside my terminal, I'll execute the test, and the test passed. So for swapping 10 DAI worth of WEF, the profit that we got is roughly 24 cents.